Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So I'm really pleased today to welcome Ellen Voorhees, who's visiting us from Nist, where she's the manager of the Text Retrieval Group, the Retrieval Group? Just Retrieval Group, which encompasses a range of technologies. I'm sure you're familiar with many of these evaluations like TREC, and a new one, TREC Vid, and a newly forming group set of evaluations called TAC that I'm sure Ellen will be telling us all about. Ellen's background is a PhD in information retrieval from Cornell, working with Gerald Salton. She joined Nist then after 10 years at Siemens, where she did a lot of interesting work that I remember really well with WordNet and information retrieval back in the 90s. So I won't belabor this, but thank you, Ellen.
Yeah. So thanks very much. I'm glad you could be here today. I'm going to be talking about some of the language technology evaluations that we're doing at Nist. Yes. And one of the things that one of the questions I frequently get is people who, not necessarily meanly, but just wonder, why is it on earth that Nist does this at all? Right? Why should Nist care about language evaluations? And so here you have, up at the top of the slide here, the official Nist mission. So just to make sure everybody knows it, Nist is the National Institute for Standards and Technology. It's part of the federal government's Commerce Department. And so therefore its role, it's also the home of the national clock, right? So time, Nist time, is from Nist. It is the home of the nation's kilogram. It is the home of the definition. Well, the kilogram is actually still an artifact. Right? There are a lot of people at Nist working to make that not an artifact anymore, because all the other standard units of measure are now defined through other processes, such as the meter is the length, the wavelength of some element at 0 degrees Celsius, et cetera, et cetera, et cetera. Information technology hasn't really quite gotten at that level of standardization. But the Nist mission as a whole is to promote innovation and competitiveness by advancing measurement science, standards, and technology. And we fit in this quite well by our group's mission statement is then to do that promotion of innovation and industrial competitiveness, but focusing on information technology problems. And one of the reasons why it makes sense for Nist to be running these sorts of evaluations, and I'll get into what sorts in a moment, is that we're a technology neutral site, by which we mean we don't actually have an axe to grind about whether or not we want to do your retrieval or your entailment by Bayesian networks or by rules or whatever method, right? We're there to evaluate the end result and not have to promote any particular method by doing that. And at this point, we have a reasonable amount of expertise and experience in operationalizing these tasks and evaluating whether or not the evaluation itself is actually accomplishing what we want it to accomplish. So within the retrieval group, the most well-known of our evaluations is probably TREC. TREC started in 1992. It's a workshop that focuses on building the infrastructure for evaluating text retrieval systems. I have text in parentheses there because we have branched out into some other sort of media, but mostly we're still concentrating on text. And the three main things that TREC has done is create realistic test collections, a standardized way of evaluating retrieval, and then a forum for exchanging these results. And as I said, it started in 1992, so at this point we're now in our 17th TREC. And over the years we have run on the order, well, it started with just 2 tasks, so these tasks here. But we have branched out into a variety of different tasks over the years. And I mostly have this slide up here just so you get the idea that it is not a single monolithic thing. There are these individual tracks, and each TREC sort of has its own combination of tracks and its own combination of things that people are focusing on. And so if you take the whole set of these different tasks that TREC has looked at over the years, we've actually looked at a fair number of different problems. And each of these tracks not each of them, but many of them have had individual tasks within them as well. So we're probably looking at here on upwards of about 100 or so individual tasks which have been evaluated over the years. So what good is that? Well, TREC itself did not come up with the way that retrieval systems were evaluated. It was built upon an already existing paradigm in the information retrieval community that was based on this idea of a test collection. So we're talking here now about an ad hoc search. Okay, so ad hoc meaning it's a sort of a one-off search. You don't have any history for this search. It's a prototypical search of, say, a web search or a search of any large collection. And the abstraction there was to obtain a set of queries or questions, a document set, and then relevance judgments. These relevance judgments are the things that says which documents should be retrieved for which questions. Okay? And this was originally created by Cyril Cleverden in the late 1960s. It's called the Cranfield paradigm because he was at Cranfield Aeronautical College when he did this. And the whole idea was specifically to try and abstract away the problems of having individual users while trying to evaluate search. Okay? And the idea behind it is that in order to do evaluation, you want to have an abstract task. You can't evaluate, it is difficult to evaluate the real end user task because of the amount of variability in there. So the idea was to abstract away to a task which has sufficient closeness to a real user task to be applicable to it, but to be able to control a lot of the variability and therefore be able to do more controlled experiments and get more valuable results from those experiments. And this sort of core task is what Karen Sparck Jones called the core competency of an evaluation task. So it's an abstract task which has real application to a user task, but has enough control so that you can actually learn something from an experiment. The consequences of this abstraction is that you do gain these control over lots of these variables, so you get more power for less expense at the cost of you lose some realism, because obviously you have purposely doing an abstraction here. And so whatever is not accounted for in the abstraction is a loss of realism. So is Cranfield reliable? Right? Lots of people will argue, and have argued for 60 years now, that you can't possibly evaluate retrieval systems if you're going to base it on a set of static relevance judgments. Right? Because we all know, and we do know, that number one, users are not, when a real user uses a retrieval system, their information need changes while they interact with the collection, and so it's not static. We also know that if you give the same set of documents for the two people who have putatively the same information need, they are going to consider different sets of documents to be relevant. Okay? And furthermore, we now know from having a big set of results such that TREC, the cumulative effect of the different TRECs have allowed us to look at, even though Cranfield was specifically developed to try to abstract away the user effect is still the biggest variable within the Cranfield paradigm. So if you looked at an ANOVA test of the TREC 3 results, and this was reported back in the first issue of the journal Information Retrieval, they took the TREC 3 results and did an ANOVA over those results with systems as one set of variables and the topics as the second set of variables, and looked for interaction effects, etc. And found that the topic effect was larger than the system effect. and that the interactions were significant but smaller, right? So basically what this means, the topic effect, remember here the topic is TREC E's for what question was asked. So here you are, you're trying to evaluate systems when the topic effect, so what was asked, is bigger than the effect you're trying to measure, okay? That complicates retrieval evaluation by a whole bunch. Doesn't make it impossible, but it complicates it a lot. The other thing that people will argue about and whether Cranfield is at all meaningful is the measures that you use to evaluate the effectiveness. Right, there is a whole slew of different measures that you might use. TREC Eval, which is an evaluation package that you can download from the TREC site, reports something like 109, I think it is, different numbers for any run that you give it. And we also know enough about looking at these evaluation measures to know that different measures really are measuring different things. That's what I mean by they represent different tasks. So one of the more common measures is precision at 10. Precision means how accurate were the set of documents that you retrieved. So precision at 10 means how many of the top 10 documents on average were actually relevant. Right? It's a very understandable measure, very intuitive of what it means. It is in fact a fairly unstable measure because it's based only on the top 10 documents. Okay? But that's a very different sort of task that's being measured if you're only looking at the top 10 than if you're looking at something like mean average precision, which is the measure that frequently gets reported in the literature, which looks at the entire set of documents that are retrieved based on very many more documents retrieved, doesn't have nearly the intuitive understanding of what that measure actually means, though. So, as I've already alluded to here, these measures mean different things, but they also have different inherent stability. The mean average precision, because it's based basically on the entire set of documents are retrieved, it's a much more stable measure than precision at 10. So how, if you're evaluating your stuff, how does that all interplay? Well, we have taken the TREC results and we've done a number of studies to try to show what actually is happening under these numbers that get reported. So the first thing I want to show here, I'm going to go through these all very quickly, but I wanted to show is it really is the case that these averages and everything is being reported on averages because we know that the variability, because we know that individual topics the topic effect is so great that individual topics are not particularly meaningful when trying to evaluate systems. You want to take averages over lots of topics, but those averages hide a lot of stuff. Here, the big red line, thick red line, is the average recall precision graph for a set of 50 topics from this run. And the little tiny lines are the individual topics that is an average of. Okay, it's only actually like 20, I think, of the 50. Because if I put all 50 up there, then you can't see anything. But you can see that it really is. This is one run. It gets reported with this nice little typical recall precision graph. But this is what it's hiding. Some of those topics, it worked really, really well, because remember, your best point is up there. Other topics were really, really bad. Right? But all you generally see is that big red number. I mean, actually, you're sometimes lucky to see even a whole recall precision graph, because frequently one number gets reported. Okay, so that's what's it's behind the numbers. The other thing then we looked at was, well, okay, we know that relevance judgments do change. How does that affect the evaluation results? So one of the things that we did was we asked different people. We have these assessors that come to Nist. They're actually retired information analysts from the intelligence community. Normally, because we know that different assessors have different opinions about what's relevant, each topic gets one relevance judge. So they're the judgments are at least internally consistent, even though they only represent one person's opinion. Right? What we did another time, though, or two other times, is we gave those same query and the same set of documents that were retrieved by the systems, and we gave it to a second judge, and then we gave it to a third judge. And we did that for all the 50 topics in the TREC 4 ad hoc test set. And then since there were 50 topics and we had 3 judges for 50 topics, I could create the different set of relevance judgments for the whole 50 topics by choosing one of those 3 judges for each of the 50 topics. So we have 3 to the 50 different sets of relevance judgments, right? Now, that's a whole bunch, and I didn't create all of those, but I created 100,000 of those. And I evaluated the same set of runs, so this is exactly the same set of runs, that retrieved exactly the same set of documents because it's the same run. And I evaluated them using each of those 100,000 different relevance judgment sets. And what's plotted here in the bar is the minimum and a maximum mean average precision value that was obtained by that one run over the different relevance sets. And you can see that there is a range, right? Each of these runs actually does have a fairly big spread about what that one particular one would have been evaluated depending upon who we had used as assessors. But the important point here is the scores that any particular run gets using a given relevance set of judgments is highly correlated with, for each of the runs is highly correlated depending upon which set of judges you use. And let me say that again better. If you look at the individual scores, so for instance, the red triangle, that was the official TREC 4 set of judges. If you use the same set of relevance judgments for each run, you will see that they stay basically in the same order. What this means is that we have hard judges and we have lenient judges, but all of the systems generally rank the same in the same order if you use the same judger for those 2 different runs.
So I just have a question about your reliance on these judges from the intelligence community.
Mm-hmm.
So I suppose it's good in a sense because their whole life has been about learning the spec for how to make judgments. But it seems like, aren't you getting a sort of picture of what relevance is versus just pulling people off the street?
It depends upon what you're trying to represent. So yes, if you have some very particular notion of relevance that you want your judgments to represent, you had better use judges that represent that notion. We used intelligence analysts because when TREC began, it was specifically targeted for the intelligence community. But in fact, even these, we have it's a fairly homogeneous group of assessors because they're basically all retired information analysts. We repeated this experiment, however, with the TREC 6 one, and the second judges were University of Waterloo graduate students, which are pretty different from retired intelligence analysts, and the same thing holds. And in fact, the variation within our group and their group was not distinguishable among the variation between those 2 sets. So people just differ. Even actually, the graduate students are a lot cheaper, especially since it was the University of Waterloo doing it, and we didn't even do it. It was a lot cheaper for us. But all of this is just to say, yes, it is the case. Undoubtedly, people's opinions differ. We know that. But as long as what you're using this for in the test collection paradigm all says is all you're trying to do is compare systems, then in fact it doesn't matter because the comparison is stable. And I got to go a lot faster than this if I'm going to. Another study that we did with these set of results was to look at the differences that the inherent error rate within a measure. And basically we looked at this set of different measures, so precision at 10, precision at 30, average precision, R precision, and recall at 1,000. If you don't know what all those measures are, don't worry about it. Basically the idea is if you create, the 2 main things to see here is if you want to allow for a bigger delta in between the time you conclude the 2 systems are different. So remember, all you're doing here is comparing 2 systems. You have a score, say a precision at 10 score for each of these 2 systems. If one score is 0.1 and the other score is 0.9, you probably want to consider those 2 different. But if the one score is 0.1 and the other is 0.11, you probably don't want to consider those 2 different, right? So this fuzziness value is the percentage of the maximum score which is considered to be different. Right? So 3% of the 3% of the bigger score the difference between the scores has to be at least that in order to consider the two scores different. And here it's 5%, and et cetera. The bigger score difference that you require, obviously, the smaller your error rate is going to be. And here the error rate is looking over multiple comparisons and looking at whether it's the conclusion is that system A is better than system B. If you look at, again, at a different version of that A and B, the number of times it says that B is better than A. We did this using a set of the same set of topics, but different queries, and which we developed which we got this data from the TREC query track. I don't want to go into that detail. I know that wasn't very clear, but if you have lots of if you want lots of details about that, ask me later. Right now, all I want to say is different measures have different inherent error rates. There are some measures which are inherently less stable than others, and it's not really a big surprise. It's just that this shows it. And the reason why they have inherently different error rates is largely just related to how much information is encoded in that measure. And precision, which is a very common measure and which people like for a lot and for good reasons, happens to be a very unstable measure, because the only thing that you really can base this measure, that the value of that measure depends on, is the number of relevant documents at that cutoff. Doesn't matter how they're ranked before it or below it. And in order to change your retrieval system and to change that score, the only thing that matters is if another relevant document entered that set or left that set. Right? So that's a very impoverished measure. It's a very user-friendly measure, but it's a very impoverished measure. And it is, the precision is one of the less stable measures. Yeah.
I understand this, and I think it's great to look at these measures. But there are cases when what you really care about is precision at 10 or precision at 1 or something like that. Do you know how this changes? Do you know how the inherent error rate changes if you add more queries, for example?
Right.
So if you add more queries, that should reduce your error rate.
It goes up. I mean, the error rates go down. Your stability increases.
Looks like it.
It's funny you should ask.
Oh.
So the next thing we looked at was how error rates depended upon topic set size. And the big thing, again, here to see is that the more topics you have, the more stable your evaluation becomes. Where once again, stability here means that you have consistently are saying the same system is better in your comparison. Okay. Again, these different lines are dependent upon the difference in the score that you're using to decide whether or not systems are actually different. And this particular graph is just showing mean average precision, but similar sorts of graphs, except starting at higher error rates, are for precision. I mean, that holds for precision and it holds for other measures.
Have you also looked at the error rate over the range of map values, say? So maybe map is more sensitive at the higher range of the values than at the lower range of the values? Something like reciprocal ring certainly is.
Right.
Right.
We have not looked, or at least I have not looked specifically at the absolute value of the measure and how sensitive it is at the absolute value, except for to say that obviously if you're requiring some given distance between the two measures and the result is very poor, you're not even going to get to that level. So very poor, very low numbers of your measure, where when higher is better, very low numbers are actually quite stable, but that's because you have no room to be unstable. Once you get to 0, 0. So yes, it's going to be, it will be somewhat more unstable at larger numbers, but that's only because you have more room to have fluctuation. At least part of the explanation is because you have more room to fluctuate. All right. All of this was to say that we've spent a fair bit of time trying to look at the Cranfield methodology to see what you can and can't learn from it. And me, being a TREC person and being a big fan of the Cranfield paradigm, comes to the conclusion that Cranfield is both reliable and useful. Right? It's reliable within certain parameters. Right? It is not and it will not answer every question that you have. But for the purpose of comparing retrieval system behavior, it is quite reliable. And it's useful in the sense of what this graph is showing you is the improvement in ad hoc evaluation over the first 8 years of TREC. This is for one system. This is just the SMART system, which was from Cornell and Sabre. What they did is they kept a frozen copy of their system each year, right? Because if you have a new test set each year, the test sets itself might be harder or easier, so you can't really just compare scores from year to year because that's not a fair comparison. But the SMART group kept a copy of their system for each year and ran each new test set with each system. And basically what these graphs are showing is that retrieval performance basically doubled between TREC 2 and TREC 6. Now, while this is only one system, the SMART system was among the top systems in all those years, so it's representative of the field as a whole. And then it also says that ad hoc performance has leveled off since then. Why has it leveled off? Partly because TREC went into all these other different tasks, and so people were concentrating on other tasks, and partly because it's not clear where the next big improvement is going to come from in retrieval systems. Now, I wasn't going to do this all just on retrieval. I wanted to use that whole part there as sort of a lead-in of what type of evaluation do we then want for other types of tasks and other language tasks in particular. But from using all that as background, what makes then a good evaluation task? Well, you want it to be an abstraction of some real task. And that's actually not as easy as it sounds. And in particular, the entailment task, which I know some of you are involved with here, is actually, I would claim, not an abstraction of a real task. There is not going to be an actual user task in which you're going to ask someone, is this sentence entailed by that sentence? And that does affect the way that you can build the evaluation, because now when you have questions about, well, should we be trying to weight this part heavier than that part or whatever, you don't have the real task to go back to and say we should do it because of this. We just have to say we should do it this way because we think so. All right. But anyway, you want them to be an abstraction of a task so that you can control the variables. You do need to control the user effect here. But of course, it has to capture the salient aspects of that user task, or else your whole exercise is pointless. You want the metrics to accurately reflect the predictive value of this thing, right? So you don't want your metric to give really high scores to that system which is actually the worst of, right? You want your metrics to reflect reality. And then you get into some more sort of meta-level things, as you have to have an adequate level of difficulty, right? If you make the original task too easy, everybody does well and you learn nothing. People are happier, but you don't learn anything. If you make it too difficult, you again don't learn anything because everyone does abysmally and you don't learn anything, but now people are angry. So if you're going to err one way or the other, you might as well make it too easy. But still, you want to actually try and hit a sweet spot where the systems can do it, but it's not a slam dunk. You would really like your measures to be diagnostic, by which I mean if you have a measure that says you're 50% of what the maximum value of that measure is, it would be good if you could actually, that measure sort of actually shows you where it is that the problem is, right? So where you, in this case, is the system builder, right? You'd like to know what the problem is. And it's also best if your infrastructure that is needed to do this evaluation is reusable. And that's best in the sense that it helps the community more because there will be more available, but it also makes costs bearable if you can then reuse it. Now, there isn't any evaluation task that I know of that meets all of these in all aspects, but those are the types of things that you want to shoot for. So as Bill mentioned, one of the things that we're starting at Nist this year is the Text Analysis Conference. And basically the idea here is that we're trying to create an evaluation conference series that would be for the natural language processing community as TREC has been for the retrieval community. It's the successor to the Document Understanding Conference, DUC, which has been going on for several years now. DUC has been focused specifically on summarization. And summarization is now still is a track in this inaugural year of TAC, but we've also taken the question answering track from TREC and put it into TAC, largely because the approaches to question answering these days are much more natural language processing centric than they are retrieval. Ken, you look unhappy.
Noted, but yeah, I'm just thinking of the bad jokes about ducking and tacking.
Yeah, well, it was an incredible fight to get people to agree on the name of this conference. Ask Lucy sometime. Lucy was involved in this argument. So. Okay. Right. And so we're keeping TAC. And the third part of TAC this year is going to be a textual entailment task, both making a two-way and a three-way decision. I'll get into what that means in a minute. So what I wanted to go through now was sort of a more detailed explanation of how we go about defining a new evaluation task when we're sort of starting from scratch. Like I said in retrieval, we didn't start from scratch, right? Cranfield was already well established by the time TREC started. But then we came up with this idea that we wanted to test question answering. And that was different from retrieval, right? And so how did we go about defining that evaluation? Well, one of the things we started with was saying that we wanted to start with factoid question answering, right? So these are little text snippets. And we wanted to, as opposed to, what's the best way to fix my washing machine, right? No. We want a little short answer based on facts, right? So how many calories in a Big Mac? Who invented the paperclip, right? These sorts of little factoid questions. And we had the systems return ranked lists of document IDs and answer strings, where the idea was that answer string was extracted from that document ID, and the answer string contained an answer to this factoid question. We started with factoids because of my previous slide where I said we wanted tasks that were of adequate difficulty. When we started this task, we had no idea how well systems would be able to do. But we had a pretty good belief that answering factoid questions were going to be a heck of a lot easier than answering process type or essay questions. We also had a reasonable idea about how we could go about evaluating factoid questions because we were expecting a single answer, and it was either was that answer or it wasn't that answer, and we could compute scores from that. And we did that for several years, and it worked reasonably well, and the systems got better. And then we hit in TREC 2001, so the factoid answering question track started in 1999. So 3 years later, we looked and we saw that about 25% of the test set, which we had extracted from logs, one of which was donated by Microsoft. So this was web search logs. We took the questions from those. About a quarter of the test set while could be answered in short, they could be answered in little short phrases, they weren't really these factoid type questions. They were much more definition questions. Right? So what is an atom? What's an invertebrate? Who's Colin Powell? These types of questions were hard for the systems to do, but it was also hard for the assessors to judge, because what's an answer to this question, right? And it depends critically upon who the user is, or at least what the use case is, right? So is the person who is asking what an atom is a second grader writing a book report, or is it a atomic physicist? No, probably we aren't going to get an atomic physicist asking our system what an atom is, but you get the idea here. And there's also this problem that looking through a huge corpus of newswire documents probably isn't the best way of answering these definition questions, right?
Yeah, well, this kind of question is, what if the result returns something related to Wikipedia answer, which seems to be right?
Well, remember we're at 2001 here, so Wikipedia isn't as popular as it was. But these days, yes, people do go to Wikipedia to answer these questions, and we can get to that. But yes, you've hit the right. The idea here is newspapers aren't the place to go looking for answers to this type of thing. So what we did is we actually created a new task, which was specifically focused on doing definition questions. So where definition questions here mean a what is object or a who is person or a who is company type of question. And the problem with trying to evaluate that is we now have to define what a good answer is. And there will be different parts of that, what's a good answer. One will depend upon what you're assuming your user base is. But there's also how are we actually going to evaluate it in terms of giving scores. Because what we really want to do is reward the systems that retrieve all of the concepts that they should have retrieved and penalize them for retrieving concepts that they shouldn't have retrieved. But what's a concept, right? And in particular, concepts can be expressed in very many ways. And so we're back here to all the problems that we have when we're trying to evaluate natural language processing systems of there's no one-to-one correspondence between the things that we want and the way they might have been expressed. And now we're going to have to deal with that. And in particular, we decided that we were going to evaluate these definition questions, or that a good way of evaluating these would be by recall and precision of these concepts. But these different questions had very different sizes of what should have been retrieved, right? So a very, very specific question, like one of the ones we had was what was some sort of, it was some sort of circuit that was used in laser printers. I mean, that was pretty much all it was. It was a circuit that was used in laser printers. Versus who was Colin Powell, right? I mean, what do you return for Colin Powell? So there was very much more would get returned for Colin Powell than the circuit. The first way, and this, we had a couple pilot evaluations of how we were going to evaluate definition questions. And this was all part of the work that we were doing with the Acquaint program. Acquaint was a question answering program sponsored by what at the time was ARDA, which was an intelligence research funding group. They're now IARPA. And the idea of the first one we were going to try, the first evaluation we tried was we were just going to say, okay, we're just going to give, systems are going to retrieve snippets that they have retrieved out of these documents. They're going to put these snippets, they're going to collect all these snippets, we're going to give those snippets, the whole set, the whole bag of snippets to our assessor. The assessor is just going to say, on a scale of 0 to 10, I think this is a 5 as an answer. Where 0, completely worthless, and 10 was the best possible answer they could imagine. But they were going to do it actually 2 scores, one on content and the other for presentation. And those of you who are summarizers will know that presentation is a big thing here too. And we decided, okay, we'll use a linear combination of the 2 scores, and that will be the final score, and that will be it. And by and large, that didn't work. It had a couple of good things. It does give you an intuitive feeling for what a human thinks of this set of facts that gets returned. And it's not really possible to game that score. All right. On the other hand, the differences among the assessors whose scores they were assigning, because they sort of had their own, each assessor has their own sort of baseline. The differences in the scores among the assessors completely swamped any differences in the systems. I mean, just no contest. There was no signal there, right? It was all noise. And this score doesn't help the system builders at all, right? The fact that I think that this summary is a 7, now you go change your system, right? I mean, what are you going to do, right? So we tried another thing. We tried what we call the Nugget-based evaluation, and here we had the assessor actually go through the corpus and the responses that got returned by all the systems and create a list of what I called nuggets. These are concepts that the definition should have contained, right? And we asked the assessor to make these atomic in the sense that they could make a binary decision about whether or not that nugget appeared in a system response. That was our definition of atomic. And then not only were they to make up this list of things that should appear, but they would also then go through back and mark ones that absolutely had to appear in the definition for that definition to be considered good. So these were the vital ones. And then concepts that could have appeared in it, it was okay. They weren't offended by the fact that this fact was there in this definition, but it didn't have to be there. And those things, those facts which, while true, they didn't want to see reported, they should never have even made nuggets. Okay, so that doesn't even make the nugget list. So nuggets are only those things that the assessor either definitely wants to see or is okay to see in a definition of this target. Then once they created that list, they went back to the system responses and they marked where in the system responses these nuggets occurred, if they did, at most once. Okay. It could be that an individual item returned by a system had one or more concept or 0 concepts, right? And maybe none of the nuggets were actually in it. Here's an example. So one of the questions is, what is a golden parachute? The assessor created the set of nuggets shown here on the left, those 6 things, and the ones in red, the first 3, are the ones that this particular assessor thought was important, that had to be in the definition. One particular response from a system is shown on the right, and those are the nuggets that the assessor assigned. Right? So that means that the assessor saw in the response A from the system both the fact that it provides remuneration to executives and that it's usually generous. Nugget 6 was in item D. F didn't contain anything or else contained only duplicates. We didn't distinguish between that. Now from that set of things, we can now compute recall. We can compute how many of the nuggets the system should have retrieved, it actually did retrieve. But we still don't have any precision there because we don't know how many concepts were actually contained in the system response, right? How would you consider to be the big payment that Euler received in January was intended as a golden parachute? How many nuggets of information is contained in that? Right? Who knows? We actually did ask a couple of assessors to try to enumerate all of the, and we tried it ourselves, where ourselves means Nist staff. So I even tried one of this. It's impossible. You cannot possibly say how many nuggets of information are in a system response. So what are we going to do about precision? We punted. And we took a lesson from the summarization evaluation, which was going on at the time, and we just used length. But the idea being that the shorter the response that contains the same number of nuggets, the better. Okay? So a system's got some basic allotment of space, and then their score started going down once they exceeded that length. So now, once we had that definition, we wanted to do some of the same sort of evaluation of the evaluation that we had done with some of the retrieval stuff. And we wanted to look at a couple of things, one of which is mistakes by, so differences in scores are going to come about by a variety of things, one of which is mistakes by assessors. Now, when I report scores and things to participants on our evaluations, they're always horrified at this idea that there might be mistakes. And my general response, and my response now will be, get over it, right? The assessors are humans, they're going to make mistakes. Deal. We try to make sure that there are as few mistakes as there are, and we try to make sure that we set things up so that they will make fewer mistakes, but there are going to be mistakes, and there were mistakes. In this particular case, we could actually measure the mistakes because there were some things which were actually duplicated. Some systems actually submitted the exact same thing more than once, and we didn't have any mechanism for catching that, and they were judged differently on occasion. So that's not a difference of opinion, that's a mistake. But there were differences of opinion. There were differences of opinions even in factoids. There's certainly going to be differences of opinions here. And the sample of questions. Some systems might just be able to do some particular type of question easier than they can do another. We did, for a couple of these, go ahead and have the questions independently judged by two assessors. And what we saw was roughly the same thing. Well, no, actually it wasn't really the same thing as for retrieval. And here, they were highly correlated again. But in this particular evaluation that we did, we got swaps where one system would say it was better than the other, and if you changed the assessor, it would be the other way around, with fairly large differences in scores. And differences in scores, the difference in score that you needed to be confident that you weren't going to get these swaps was bigger than the differences in the scores that the systems were producing. And that's obviously a problem. And here again, we also did the same sort of thing where we were looking at the number of questions that you would need in order to drive that intended error down below 5%. And it ended up, as I said, bigger than with the differences that the systems were producing. And so our only thing we knew to do there was to increase the number of sizes of the questions that were being asked. And so I've labeled this try to prime, because what we then did from that, starting in TREC 2004, we basically made the entire test set for question answering definition questions, where it was structured such that there was a set of targets. The target was the thing you were trying to define, and then there was a series of questions about that target. So we actually had multiple individual questions all about that same target. And this allowed us to do a couple of things. One, it allowed us to have 75 rather than 50 definition questions, because the entire thing was all focused on definition questions now. But it also allowed us to do a little bit of context, only a little bit, but a little bit of context within these series, because within the series what we did was we started to use pronouns and things to refer both to the target and to previous answers, which doesn't sound maybe like a whole big thing, but was a really big deal to the question answering systems at the time, because now they had to deal with that sort of anaphora. And most of them didn't deal with it well, at least the first couple times. They were told within these series what type of questions the systems were told. They were told that this is a factoid question or this is a list question. And that was basically only because we had different reporting. The type of response that they had to give differed depending upon the type. And one of the other things that we've just since then done to make these definition questions even more stable, remember way back in the beginning there, I said that the assessor had to say whether or not a nugget was vital or just okay, right? And if it was okay, then basically we ignored it in the scoring. That was the upshot of the way it was scored. A okay nugget was just treated as a no-op. They didn't get penalized in length, but they didn't get any credit for retrieving it either. And if you're using one person's opinion on that, it's really unstable. And so instead of doing that, since creating the nugget list is the expensive part of this evaluation, because the assessor has to sit there and go through all these things and think of what they want, and et cetera, once we have one assessor create the nugget list, but then we give it to all 10 assessors, we generally have 10 assessors doing this, to ask whether or not they think this given nugget is vital. And in using the number of assessors who think that it's vital And that's sort of analogous to the pyramid evaluation in summarization. We weight the scores depending upon how many of the assessors thinks it's vital. And that just gives a nice, more smooth evaluation measure, and therefore makes it more stable. Okay. One of the problems with the QA things, though, even the factoids, is that it's not reusable in the sense as Cranfield test collections are reusable. We have some partial solutions by this in the sense that we make answer patterns that we assume to be, if you retrieve a factoid response, you retrieve a response for a factoid factoid question, and your answer matches this answer pattern, like it's a Perl pattern, we consider it correct, and if it doesn't, we consider it incorrect. That can go a long way, but you can game that. You can make answers strings that match the patterns but are in fact not correct. And the problem of why they aren't really reusable is that we still don't have a solution to this problem that have unique identifiers, right? Once you have unique identifiers, which document IDs do in Cranfield, then you're sure that this is the thing that should have been retrieved. But in the absence of unique identifiers, you're still back in this sort of squishiness and don't have real reusability. And the problem with not having real reusability is that it makes it much harder to learn, to train systems and to learn from previous evaluations if you can't get comparable scores for while you're creating your system. We still don't have a solution to that. I think I probably don't have enough time here to go through the entailment. Just let's say, basically to say that we did have, for the entailment task is to decide whether or not a second sentence must be true given a first sentence. I got a couple examples there. And Nist was part of the textual entailment evaluation that has been running the past couple of years. Last year, in that we added in the original definition of the entailment, you simply said that yes, it was entailed, or no, it wasn't. But no, it wasn't includes both can't possibly be true and just simply isn't entailed. And so we split that out into three ways. So no, so it's either entailed, contradicts, which is no, it can't possibly be true, or neither. It doesn't contradict, it isn't entailed, it just, it's sort of unrelated. So you can see the first example here is an actual contradiction. The second one is a neither entailed nor contradicts. And the upshot of this was we then went through, we used the exact same test set that was used for the two-way case, and the exact same evaluation measures, et cetera. We figured all that would be fine because it was fine for the two-way case. But then we looked at the results for the three-way case, and we realized that because accuracy, which is the measure that's being used, is still based on this, it has to be exactly, the system get their point for only if they give the exact answer. So whether it's yes, no, or neither, they still have to give that answer. So for these systems, it's still a binary score, but now they have three choices. And that lowers the human agreement rate because the humans also have three choices. And it lowers the human agreement rate such that the evaluation that we used last year for this three-way was unstable, meaning the differences that the systems were reporting were within the error bounds that we could confidently rely on among the human agreement. So what do we do there? Well, we can add more cases, but how many? We don't know how many more. So what are we going to do for TAC? We're going to add some. Last year it was 500. I think this year it's going to be 900. We can change the measure, but to what? I don't have any brilliant ideas on what measure, so for right now we're leaving the measure as it is. We can get more annotation agreement, right? We can sort of force the assessors to agree more, but that only works, right, by making up rules, and those rules are only reasonable if they actually represent phenomena you want to be represented, right? Arbitrary rules just to get for the sake of agreement doesn't help anybody. And the other thing that we can do, and we probably will do, is if two assessors disagree, we'll just make the official answer neither, because that's sort of good evidence that the answer is it neither contradicts nor entails because the assessors can't agree. And that's sort of a sub-case of forcing more annotation agreement. So my case here through these community evaluations, coming from Nist, I need to be but I am a firm believer in being able to measure things, to be able to really concrete, give a number to things. But they form and or solidify an already existing community. They are instrumental in establishing the research methodology for that community. They facilitate technology transfer. They can document what the state of the art currently is. That's helpful, especially for students who want to start coming in to see sort of where it is that they need to start from. And another nice thing is they amortize the cost, right? It's much more cost effective to have one central place creating all this infrastructure that is needed to do these evaluations than to have everybody off in their own research grab doing the same, recreating different, incompatible, but as expensive infrastructure. Now there are some downsides. These evaluations do take resources that could be used for other things. There's the researcher time, and there's the money to defray the evaluation costs. We try to minimize this effect by keeping the tasks that are for the evaluation only, such as the reporting format and sorts of things, as simple as possible to make those costs as low as possible. And then we also have the problem of overfitting. Once a data set is out there, right, the entire world now uses that data set, and you get this entire community who has now decided that 3 percentage points of F measure over this one data set is the be-all and end-all of their research, right? That's a problem. Especially because any given test set is going to have some peculiarity, which you don't really want people exploiting that peculiarity of the data set. And we try to minimize that effect by having multiple test sets that evolve, just the same way the question answering evolved throughout its lifetime, to try to both make sure that we're testing the things that need to be tested as the systems get better, but also to prevent this extreme focus on what is almost certainly insignificant performance improvements. And that's it. Thank you.
So I should say before questions that Ellen has a little bit of time this afternoon still, and then we'll meet with her at research. We're going to talk to her. Questions?
Ken?
So you mentioned, this was a long story about a rather specific case, but I think there's a bunch of sort of more generalizations that could be pulled out of this of what would be good desiderata for an evaluation. You mentioned costs and various benefits like reusability and so on. And then many times you sort of longingly referred to the Cranfield and things as a sort of poster child of how it might be and how you wished that you could have made this example fit that. Now what I'm kind of wondering is if we could roll back the clock and knew what we knew then and not what we know now, would the community have all been united and agreed that Cranfield was just a wonderful success on all the things you were describing? I kind of have the feeling that for a long time, say Jerry Salton was working without as many resources as we have today, and there wasn't such a consensus that it was such a great success.
Okay, there's a couple of answers to that. One is Cranfield has never enjoyed, and still to this day does not enjoy, a community-wide acceptance. It probably enjoys its acceptance more now than ever, and that's largely due to TREC and related things, because because I will claim at least that we've demonstrated that it really has real benefit. Having said that, there's also many, just go to any SIG-IR and look at one of the workshop. There's bound to be one workshop on why it is that Cranfield is so terrible and what are we going to do about it, right? And they have many good points in there, which is particularly Cranfield does not represent the user in the way the people want the user now represented. there's, in my opinion, good reasons why Cranfield doesn't represent the user. Right, it specifically was trying not to. But it is not going to be, Cranfield is not the abstraction that people who are interested in how users interact with search systems can use. Right, it's just not the right abstraction. There are people working on trying to extend Cranfield to be that to be such an abstraction, and I have worked some with this and trying to how would you do that, and I'm personally very pessimistic, because anytime you try and change Cranfield even a little bit, the costs skyrocket because you've introduced a lot more variability and now you can't conclude anything anymore. I mean, without much more large scale efforts. The one thing that I did, you said, sort of I kept longingly looking at, the one thing I would like these other evaluations to produce, which Cranfield does and these don't, is the reusability. And I recognize why these don't produce the reusability. It's the lack of a unique ID, and I don't know how to insert a unique ID into them. But until you get that reusability, or at least some very good close approximation to reusability, the data sets are not nearly as useful for researchers. They're basically only evaluation data sets and not training data sets.
Have you ever considered using something like a mechanical Turk to evaluating how good that is?
So the short answer to that question is yes, I have considered it. The longer answer is, as a Nist evaluation, it's not going to happen. I am not allowed to use mechanical Turk because we can't give U.S. government funds to a private company in escrow to hold for. So mechanical Turk as such is not going to happen.
If somebody else funded it, could it happen?
If somebody else funded it as them funding it and them running it, it could happen, and I could report it, and I could use those judgments perhaps, but
I'm just asking.
yes.
I mean, we're not talking about a lot of money.
No, I know that. That's why I was interested in it.
So if it's a small amount of money that just fell off a truck.
Especially when you say that graduate students are as good as your evaluators.
Right. No, we're not talking about large amount of money. I know that, but
right. I mean, you can't spend red dollars for green things.
Right.
But, But if somebody else could.
Right. And well, actually, I mean, there are lots of people. Well, not lots, but if at this past, ACL, there were a reasonable number of groups that had in fact gone out to mechanical Turk to get different types of annotations.
Truck, you could reuse it, right?
If something fell off a truck, I could reuse it probably, yes. Lucy?
The evaluations or the judgments for the RTE, so there were 2 assessors.
Okay, well, the way this, and yes, last year's RTE worked, is the people who created the test set, which was the Select organization in Italy. They had at least 2, it might have been 3, but it was at least 2 assessors, both selecting the pairs and making whether or not it was entailed. And if they disagreed, it didn't get into the test set at all. Okay, but then when Nist went to do the 3-way, we decided, we might as well, and I had all of the Nist assessors who were doing this. No, I had Nist assessors who were doing this judge such that the union that they judged was the entire test set. And I did that because, or I didn't necessarily have to do that because we did not change anything that the RTE said was entailed. We left, that the original RTE test set said was entailed, we left as entailed, despite what our assessor said. And I knew that we were going to do that, so I didn't necessarily have to have our assessors judge those ones. But I did anyway to see if there were disagreements. And in fact, there were disagreements.
So in this case, there disagreeing? Because I'm interested in what the disagreements are.
Okay, I'm sorry, I misunderstood what you're
No,
saying.
no, no. All
the-
of this was helpful.
The disagreements were things along the lines of, the one I remember very particularly was there was a pair that that hinged on whether or not Hollywood and Los Angeles were the same. And the Italians said yes, and our assessors said no. There was another,
How close you were to the scene.
right, there was another one where there was East Jerusalem did such and such and such and such, and the text said Jerusalem, such and such and such and such. Now, is East Jerusalem a part of Jerusalem? No, is it the same? Yeah, well, maybe, but is West Virginia part of Virginia? No. Right, so.
It used to be.
Well, yeah, but, but that doesn't matter anymore, right? There was another one where two Italian politicians, and I wanted to see why this disagreement was, so I actually went on to Wikipedia to see who these people were and why this was. Apparently these politicians were in the same party, but they were opponents within the party. So the question said such and such and such and such were opponents. Where from the text you wouldn't possibly have known that they were in the same party, right? And so the Nist assessors said they were not opponents. The Italians said they were opponents. Right, it's so you really, even at this little level of textual entailment, the context and the world knowledge that you know really matter.
I mean, it would be interesting.
I have all the judgments that Nist made. I kept them all, yes.
Because in terms of the challenge, the remaining challenges for RTE, this would be a very interesting set. Where is world knowledge truly
Needed,
required?
right.
We had a similar experience where we tried to use people in India to judge our HRS process. And we found that they had a hard time, say, distinguishing between American issues and British issues. Things like this. They
Right.
wouldn't know the pop stars, the latest ones.
Right.
They might know the
Well, neither
pop
will I,
stars,
but-
knowing Jacksonville Jaguars is relevant here is like difficult.
Right. All of which is just to say, as much as we might like to make these, and we in fact we tried to make these evaluations sort of independent from things which aren't specific to what's trying to be tested, you really can't do that. We can try, and I think I personally think it's a good thing to try because we want to control as much as we can, but we do have to recognize that we aren't going to get it eliminated completely. And what do we do with those cases? That's another interesting question, right? If you can't get humans to agree, we can't really expect the systems to agree. So maybe we just give them a gold star that they say they're in, there's as much agreement among this system with a human as another human. And if you can get that far, which the systems aren't anywhere close to, right? But if you can get that far, well then all good, we will have to go on to some other type of evaluation. I'm sorry, yes.
So do the assessors use external resources to label, like Wikipedia? And if so, do they use the same resources?
We're talking now within RTE.
Yeah.
To the best of my knowledge, RTE assessors don't use any external resources. It's supposed to be the case that their entailment decision is supposed to be made strictly on the piece of the text which is given. But that's really hard for humans to do, right? Humans can't subtract out what they know, right? Well, it's hard to give the systems that. It's also hard for the humans to subtract it out. And so, no, they don't really use external resources. Well, sometimes when in sort of a document judge or more question answering mostly, when we have asked assessors to judge questions for which they have no concept of the area, they will go do basically web searches to sort of get up to speed. But that's pretty much it. Because we have to make sure that it's controlled in some way. And also in question answering, I never really did get back to that. The way we at Nist implemented the question answering track we allowed systems to use external resources. They were allowed basically to use anything that they wanted, largely because there isn't any effective way of really saying what you can use and what you can't use. Right? One person's external resource is another integral part of their system. Right? It's a very slippery slope to try to outlaw that. WordNet is a prime example. Right? For some people, WordNet is an external resource, but for other people, it's just part of their system. And so we didn't try. We just said you can use anything that you want, but you have to return a document in the collection that supports that answer. And so, in fact, there were a fair number of systems who went out to the web, answered the question, and came back and projected the answer back into the document collection. Actually, Microsoft's system was one of those that went out to the web, and very reasonably, right? The Microsoft one in particular was a why try to do fancy things when you can just use the law of large numbers and go find the answer and project it back in. And you could tell systems that did that because by and large the projection didn't work well. But we did allow it, and we made our definition questions. Those questions that we selected to be part of the definition, we actually did try to make such that we didn't think it could be answered simply by going to biography.com or Wikipedia or et cetera, and scraping that and just returning that. That's actually getting harder now because the resources on the web are getting more and more complete. Okay.